All right, guys. I hope you all can hear me loud and clear, guys. My name is Prateek Agrawal. I'm going to be your instructor for today's interesting session on analyzing treatment data, medical treatment data for a large Fortune 500 company. So we will have an hour with us, and in this 1 hour, 60 minutes, I will introduce you to the world of SQL, and I'll also give you a flavor of how you can analyze large data, business data, and make sense or make decisions using that business data using SQL as a language. So that's going to be the focus area for today, guys. And I see a lot of people have joined in already. So do feel free to prompt me for any question that you may have during the session. So feel free to reach out, feel free to ask questions. Start recording as well. All right, guys. So I am going to be the lead instructor today. My background is I've spent around 17 or 18 years in this data management consulting industry. I'm a computer engineer. I've done my MS in information systems and operational research from Texas. More about me, I will share my LinkedIn ID, or you can just Google my name as Prateek IV, Prateek IV Pro or Prateek IV, and you'll find the first link as my profile in LinkedIn. Or you can send me a request on Twitter as well. I'm active in these two platforms, guys. So I'm going to assume almost nobody knows anything about SQL here, and I'm going to start with that, and I'm going to show you that how easy it is to use SQL to analyze large amount of data, guys. So that's going to be the theme of the session today. I've already shared the data file that we will be using in the chat app. So if you go through the chat app, you will see a link, a Google Drive link, where I have uploaded the data file. I'm going to talk about the data file a little later, but if you want, you can go ahead and download the data, the CSV files, which I have uploaded in this Drive link, which is shared in the chat app. Do feel free to download now, or we can download it a little later. The way I've structured today's session is first, 8 to 10 minutes, I'm going to give you a quick introduction on SQL and what is the use of it, who uses it, and why is it so famous, why is it one of the top 3 skills in the world of data science, and why not just data science, in the world of data, actually, data scientists, data engineers, data analysts, everybody uses, or everybody's supposed to use SQL in order to make the world better in the world of data. So SQL, the full form is structured query language, but don't go by the full form because it's not just used for querying the data. So whenever I introduce SQL, I always give an example that consider yourself in a room, right? And if your room, imagine you're living in this room, and if that room has a bed, but in that room, there is no wardrobe. There are no wardrobes, there is no storage place. Now, within a few weeks of time, you will realize that your stuff would be scattered all over the place in the room, isn't it? So just like a room needs wardrobes, cupboard, almirahs, storage place, essentially, organizations like Oyo, Uber, Airbnb, any organization which is generating data, and almost all the organizations in the world in today's time generate data. So they need databases or data repositories to store and manage their data in an organized, structured fashion. And why do they want to manage their data in an organized, structured fashion? So that whenever they have a business decision to make, they can query the data repository or the database, and they can get some answers to it. Say, for example, you work for Uber, and Uber wants to know which are the top 3 zones, high demand zones in a city. So that information is available based on the order history. And order history or order data points are actually stored in one of the tables in a database. So consider a database like a wardrobe. Imagine this is your wardrobe. These are the doors of the wardrobe. My drawing is bad. And just like the wardrobes have shelves in them. So consider this entire wardrobe is equivalent to a database. Let me remove this chat. Yeah. Consider the entire wardrobe is like a database. So this is a symbol of a database. Now, just like wardrobe needs shelves, similarly, the databases need tables. So a database would have multiple tables, right? Now, why do we need the shelves in the wardrobe? So that we know that, okay, this shelf is for shirt, this shelf is for trousers, this shelf is for something else, and so on and so forth. So that when you're searching for your shirt, you know which shelf to go to. Similarly, in an organization, they end up dividing the data into multiple tables and they end up storing them in a database. So say, for example, this table is customer profile table. Let's call it as customer, and this table is the orders table. All the orders placed by each one of these customers would be put into this orders table, which have rows and columns. Okay. So just like a wardrobe is divided into multiple shelves, an organization's database is divided into multiple tables. And the reason why we end up dividing them is so that you know where is what, right? So that when we are querying the data in order to make decisions, you know which table to go to. If you want to just know the customer profile, what is the customer profile? Do we have more young millennials ordering in our platform, or do we have more oldies who are ordering in our platform? That you can get to know only from the customer table. If you want to know in which zone of the city or which are the top 3 zones in the city where we are getting most number of bookings made in Uber app, then you'll just directly go to the orders table. So that's why we end up dividing the data into multiple tables. And each table has columns, which are vertical or the headers, and rows, which are horizontal, which contain the data. So that's about the database and the tables. Okay. Now, these databases are created in something called as database management software or database management system, which is a group of programs which allow you to do 3 things, which allow you to create the data, create the tables in the database, which allow you to insert the data and manipulate the data, meaning change it, delete it, and so on and so forth. And it allows you to delete, it allows you to query the data. So any such operation that we perform on the database is done using these 3 set of commands on the database management software. So that is why I'm sure, can you guys see my screen, everybody? I hope you all can see my screen.
Sir, we can see it.
All right, good, great, thank you. So a database management system is a group of programs which allow you to do 3 main things: create the tables, create the columns in the tables, insert the data into the tables, or manipulate or change or delete the data from the tables, and query the data from the tables. So any database management software should allow you to do these 3 things. Now, you as a user, when you want to send an instruction, say for example, you want to query some data from a specific table. Let's say we had orders table. You want to query the data from the orders table. Then in that case, as a user, you should be able to send instructions to the database management software. So that is where SQL comes into the picture. SQL is that language which allows any user, any reporting tool to send instructions to the database management software. Okay, so that SQL is a bridge. Just like English is a bridge, or Hindi is a bridge, or Gujarati, any language is a bridge for 2 human beings to be able to exchange information with each other. Similarly, SQL is that language which allows the users of the database management softwares, which can be a human being or can be a reporting tool, which needs access to the data. SQL allows these human beings and the reporting tools, the reporting softwares, to send instructions to the database management system. So it's the bridge. Now, then the question is, so that is why I've written here, SQL is used for inserting, extracting, manipulating the data from the database. And why is it required? Because it's a common tool. It's a common language across all database management softwares. And there are several database management softwares available in the industry. But SQL is the common language which allows you to connect with multiple database management softwares. Now, who use SQL? As I said, it could be any human being. Like suppose you're working as a data engineer or a data scientist or a data analyst in the firm, and you want to query the data or you want to send some instructions to the database management software, then you will use SQL, because the database management software, irrespective of which company it is designed by, they only understand SQL as the language. And all the reporting tools, for example, Excel, from within Excel, you can run an SQL query. From Power BI, from Tableau, from Python, from R, from SAS, any reporting tool where we actually take the data and analyze it, visualize it, or create machine learning models. These tools also require access to the data, and the data only resides in the database management software. In order for these reporting tools to get access to the data from the database management system, they also need to speak the same language which database management system speak, and that's where SQL comes into the picture. So it could be a human being, it could be a reporting software. If they want to communicate with the database management software to access the data, so they have to use SQL. Why is it famous? Because it is accepted universally. It was designed in early 1970s by two IBM research scientists. However, they made it open source, free for anybody to use. And hence, all the database management softwares used in the world today, they all comply by the same protocol, same language protocol. It's like saying English is the most famous language in the world, and hence more and more countries are promoting English internally in their schooling system, so that more and more people become part of the global workforce, especially in countries like India and a lot of South Asian countries and so forth, so that they are part of the global workforce, so that there is a common platform, common language. Similarly, SQL is that one common database language which all database software speak and all reporting tools speak, right? So that is the advantage of learning SQL, guys. Second advantage of SQL is, among many other advantages, which I'll probably not cover today, you can definitely Google, but it is very easy to learn, especially for anybody who speaks and understands English. It was always designed in an English-friendly language. Believe me, if you have never coded in your language, in your life, you can still learn SQL pretty quickly because it is very English-friendly. Now, there is a body, just like we say Oxford in the UK is like a authority or body to decide what kind of words are allowed in English, and every year they kind of expand their vocabulary in their dictionaries. Similarly, NSI, or American National Standard Institution, is a not-for-profit body which kind of decides what are the protocols available in SQL as a language, and most of the database management system kind of comply with NSI SQL. Okay, not necessarily completely compliant. All these database management softwares by different companies, they add a little bit of flavor to the NSI SQL to kind of internalize them. So if you know SQL in one of the database management system, then you can pretty much work with any other database management system with a little bit of tweaking. It's like saying that if you know English in India, you can work in the US, you can work in New Zealand, you can work in Australia, UK, any English speaking country. Yes, you'll have to change a few things. You may have to learn a few vocabulary here and there, but language largely remains the same. The same logic applies to SQL. SQL is divided into multiple statement types, mainly four statement types. Database definition language statement, or we call it short as DDL. Database manipulation language statement, or DML, and database definition language statement, database control language statement, which is called as DCL, and finally transaction control language statement, which is also shortly called as TCL. Okay, I'll just give you a quick overview. In today's workshop, we'll probably not have time to cover all of them, but you can find a lot of videos that I've also already recorded on IB's YouTube channel, where I've spoken about and given commands for all three of them, or all four of them. DDL statement, remember, any database management software should allow you to do three tasks: create the database, create the tables in it, and insert or manipulate the data, and query the data. So these are the three major tasks that any database management system should allow. And hence, the SQL statements are also divided into commands or statement types, which allow you to do these three things. If you want to create a new database or a new table, or you want to change the structure or design of a table, then you use these commands, which are called as data definition language statements: create, alter, drop, truncate. And as the name suggests, create will allow you to create a new database or a new table in that database. Alter will allow you to change the columns, change the columns names in a table. Drop will allow you to drop entire table or a particular column. Truncate will allow you to dump the data of the table. Insert will allow you to insert, which is part of data manipulation language statement. Manipulation language statement meaning you are allowed to insert the data, insert rows into the tables which are already designed or defined by using DDL command. Update meaning changing somebody's last name, changing some data. So let's say insert is, let's say a new customer opens an account with Uber. So that is an insert operation, because a new customer information will be inserted, new customer row will be inserted into the customer table. And update, let's say that customer decides to change his last name. So then that would be an update statement, changing a existing customer's last name. Delete, let's say a customer has deleted his or her account from the table, then or from the platform, then that will be a delete. Delete will allow you to delete rows conditionally. Conditionally meaning, let's say you want to delete all the customers who have not given their valid email ID from the customer table. So delete will allow you to delete rows conditionally, which meets certain condition. And within data manipulation language statement, we also have BQL, which is like a subset of DML, which basically has only one command, select, one of the most important command. It allows you to read the data or extract the data. As an analyst, as a data engineer, as a data scientist, 90% of your time goes into running a select statement, because this is the command which allows you to extract the data from a table. Let's say you want to understand the list of new customers that created account yesterday, right? So you'll go to the customers table in the database and you will select only those customers who created their account or last login or last account creation date was yesterday. So select statement, we will see today extensively, allows you to read the data or extract the data. And this is the statement which allows you to make decisions, right? So select is one of the most important statement for any SQL user to understand. The other statements also are important, but we do not keep creating a new database, creating a new table, or inserting the data or changing the data every day. But every day, every moment of time that you use SQL, you'll probably have a need to read the data or extract the data. And that's where SQL comes into the picture. Data control language statement are typically used by database administrators, the IT guys behind database, who grant access and revoke access depending upon the user profile, right? It's not necessary that you as a database user will have access to all the tables. It may be role-based, that you're part of the marketing team, so you will have access to only marketing-related tables in the database. So that can be given by the database administrators using the grant command. Transaction control language statements are majorly used to save your SQL scripts, save your data in the databases, kind of a backup planning. So we'll not go into this, but this is also can be interesting, especially for data engineers. Commit is to kind of commit the command that you've written. That means all the changes that you're making to the database, if you want to save it, then you'll say commit. Rollback is like going back to a historical state of the data. Let's say you made a lot of changes, but then you realize those changes were not good, and you want to go back to a backup of the database. So then you can roll back to a backup of that particular point of time. Save point is like creating a backup point. Say for example, today is 21st of October, and it's 6:20 p.m. In India. So you want to create a backup point at this point of time, so you can actually create a save point using this, but typically used by database administrators or data engineers. But in today's session, we will focus on being able to analyze the data, because that's the flavor of the session today. We want to be able to analyze the medical treatment data for a large Fortune 500 company. So we want to be able to extract the data. So that is why we will focus mainly on select. However, I will give you a flavor of how the databases are created and how the tables are created and how the data is imported into those tables. Since I did not tell you to install anything, and in today's time, most of the data. Yes, Sanjay, you have a question? Sanjay, you have a question? Okay, maybe not. Okay, Sanjay, if you have any question, you can always unmute or ask in the chat window. Now, in today's session, what we will do is we will create a database. We will create table, but we will import the data from Excel CSV files, and you will see it's very easy. And since I did not tell you to install anything prior to today's workshop, so we will use something on cloud. That means where you do not have to install anything. Because in today's world, most of the applications, most of these database management system, and most of the reporting tools that we use are all on the cloud, right? You do not end up installing them locally. So we will use one of the cloud service provider, one of the largest cloud service providers in the world, which is Google Cloud Platform, GCP. And within GCP, which is a cloud machine, we will use a service which allows us to create databases and to create tables and insert the data and then manipulate the data and query the data. So that platform is called as Google BigQuery platform. Okay, Google BigQuery platform is what we will end up using in today's session. Now, I don't want to take the onus of creating the database. I want somebody, one of you, to help me do it. So who would like to share your screen and do what I tell you to do? And believe me, using Google Cloud Platform to do what we will do today is...
I will do it, sir. Kirti here.
All right, Kirti, go ahead and share your screen.
Yes, sir.
Rest of you guys, we will go slow. So you can also try at the same time, or you can see the recording. I'm going to upload this recording on IV's YouTube channel as well. And you can follow it after the session also, but it's really up to you. All right, so what Kirti has done is that he has already downloaded the 3 CSV comma separated Excel files that I had uploaded, which contains the data. And we will import these 3 files into a data set as tables that we will create on Google Cloud Platform. So let's open Chrome browser. And to be able to use Google Cloud Platform for free, you just need a Gmail account. And most likely you all will have a Gmail account. Okay, so open. So Kirti, you want to share the entire, not just this Explorer window. Go ahead and share the entire screen. So you can unshare and share the entire screen again.
Okay, sir.
Go ahead and share the entire screen, Kirti.
Yes, sir.
And in the meantime, guys, I've given the link again, the dataset link again in the chat window. You can download the dataset from it. Again, you have not shared the entire screen, you just shared the Explorer window. You want to unshare again, and then on the top left-hand side where it says share desktop, please go ahead and select that option.
I have to go to the share screen button, right, sir?
Share screen, but share desktop. Choose the share desktop option.
Just a second. I'm just getting that screen option, not getting that option of that share desktop over here, sir.
Okay, the screen only. So go ahead and click on screen.
Okay, I've clicked on that. Then I'm getting that share button.
Yeah.
But once I'm clicking on that share button, the same thing.
Now I can see everything. Now
okay,
open
sir.
Google Chrome.
Okay, sir.
This is a Google Cloud Platform. It works better, not necessarily, but it works better in Chrome. So go ahead and open Google Chrome. Yeah, perfect. Now here, just search for Google BigQuery Sandbox. Sandbox is like a trial, environment provided by Google Cloud Platform. So Google BigQuery Sandbox. Now, look at the second link, which says query a public dataset with Google Cloud Console. Go and select that option. Now, scroll down, although here you can go and, in your leisure time, when you have more time, you can go and go through the each and every step here. But since, you're with me right now, so we'll go down. Now, open a public data set. Here, you have go to BigQuery. Click on this link. Yeah. So he Googled Google BigQuery Cloud Platform, Sandbox Platform, and then we went to the second link, and then we went down and we went to go to BigQuery. And this is the BigQuery user interface. And if this is the first time he has gone there, then it will ask for welcome. Now go slowly, okay? Countries, India is fine. Term of service, agree. Here, agree and continue. I mean, ideally you should read the terms and conditions, but who really reads them especially. Now, here, this is how the interface looks like, okay, of Google BigQuery Cloud Platform. Now here, you will see that on the top, it says start your free trial with $300 credit. But here, if you want to do it, yes, you will get full experience, but you will have to give your debit card or credit card information. So we'll dismiss it. We don't really need it. Believe me, you don't need it until you are doing some really hard. So go ahead and dismiss it.
Shall I click on dismiss button, sir?
Yeah. Go ahead and dismiss it. Yeah, perfect. Now this is the workspace, SQL workspace. Now here where it says select a project, or here it says create a project. So we want to create a project. Now just hold on for a moment. Here in Google Cloud Platform, the structure is like this. We create project, we create a project folder, and within that project folder, we can create multiple databases. Now, since we are using the free version of Google Cloud Platform, so it allows us to create a quota of projects, but believe me, that quota is fine. And within the database, we will create tables. And since I have uploaded and shared 3 tables with you, so we will end up importing or creating 3 different tables. So that is the structure, that is the hierarchy here. So click on a create project here. Yeah, so we're creating a project folder, which is universally available. That means it is a public project folder. Remember, because we are using the free version, so there is very less security here. Whatever project that we create, by default, will be shared with the public. So it says you have 12 projects, but within each project, you can create a lot of databases. Don't worry about that. And you can also request for an increase. So give a project name which is going to be unique. Since we are talking about medical treatment, so let's write medical treatment, but it has to be unique. You can't write the same thing what Kirti is writing. It has to be globally unique. So let's say, Kirti, you write your own name, Kirti-medical project, and give everything in small case. Hyphen. It doesn't take underscore. It doesn't take a space. It can take a space. Hyphen, not the / hyphen, and maybe write something. Hyphen. Yeah, perfect. Now this is unique. It says perfect. It cannot be changed later once created. That's fine. Now let's go ahead and click on create. Now what he has done is that he has created a project folder, and within that project folder, we'll end up creating data set or database. Okay, Google likes to call database as data set. Google likes to call database as data set. Now, welcome to BigQuery Cloud Console. That's fine. You can read the quick start guide. It's a good guide. You can read about it later, but click on done. Now, what he has done is that now it says now viewing project this in no organization. And on the left-hand side where it says the Explorer window, this is where we can see all the projects and all the data sets and the tables that we are creating. Now, here sees Kirti medical project, right, Kirti?
Yes, sir.
Go ahead and try to open this drop down. Now he will see just external connections, but we'll not worry about it. He doesn't see any databases in it, no tables in it. So there are 3 dots here. Click on those 3 dots. Now it says create dataset. As I said, dataset is equivalent to database in Google BigQuery platform. They like to call database as a data set. So let's click on data set, create data set. Yeah. So now it is asking what is the data set name. Okay, so let's give it as a medical data set. Now here it says letters, numbers, and underscores are allowed, no spaces are allowed. This has to be unique within this folder, but it doesn't have to be globally unique. So now here you can give whatever name that Kirti is also giving, input data set. Give it in small case. Try to put everything into small case because it is case sensitive, guys. Okay. Medical data set, right? Perfect. Data location. Now here, because remember we are using a cloud platform, and it is asking physically there is a data center where this database is going to be created. So in which region do you want to do it? So click on the drop down there. Select the first one, US multiple regions in the United States, meaning that you don't really care, it will be created somewhere in the US. And don't worry about the other option, just go ahead and click on create data set now. Now, what it has done is that if you notice under this project, there is a data set that he has created. Now, if he clicks on the drop down here, what will he see? Nothing. Right? He sees nothing there, which is because we have not created anything. Now, we have created a project. We have created a data set in that project. What is the next thing that we should do? What is the next thing that we should do?
Tables.
Hey, perfect. Click on the 3 dots again against a data set and click on create table. Now, This is where we will import the tables that I've already given to you. Now, before we do that, now let's go to that folder where we've downloaded those three CSV files that I had given to you. Let's go to that folder. Now let's open each one of these files and let's see the data in it. So the first table that he's opening is departments table. Go ahead and open it, please. It's an Excel CSV, so it's going to open in Excel, but it's not really an Excel file. It's a comma separated values file, which is commonly understood by any database management system. It's not a Microsoft proprietary file format. It is an industry open file format. So if you notice here, there are how many columns in this table? There are two columns in this table, department name and department number, department dep underscore number and dep underscore name. So essentially it gives you different departments. It has given a unique identifier department number to each particular department, right? You see, so there are all these different departments that we normally see in the medical industry, right? Now let's go ahead and open the next table while you keep this table open. Let's open the employees table. Now in the employees table, there are a bunch of columns here, ranging from, you can zoom a little bit. Yeah, zoom it, perfect. Employee ID, employee type, first name, last name, birth date of an employee, gender of the employee, date of joining, and date of resignation. Now, you see, what are we trying to do here? What we're trying to do here is that for this large Fortune 500 companies, which has a lot of employees, we want to understand that these employees have gone through several medical treatments through that organization, maybe part of their medical insurance, so on and so forth. They want to understand essentially what are the diseases, common diseases, how much money are we spending into these diseases, so that they can probably do some they can probably take some preventive measures, right? So here you will find, if you notice here, between this table and the department table, there is no common column between them. So there is no relationship between the employee table and the department table that we have seen. Now let's go ahead and open the third table, which is treatments table, and let's see what is there. Now, in the treatment table, what we find is that we have, so what do we have? I mean, Kirti, now you tell me.
So here we have treatment for the like what all disease are mentioned, I think. Department number is mentioned and treatment name, and last the fees, how much they are going to charge for it, for the treatment.
Okay, so we've gotten the treatment ID, department number, treatment name, and fees, right? So if you look at, let's say this particular row, so it says this is the treatment ID, this is the department number, ablation, and there is the fee. This ablation is like a treatment name, some medical treatment, and the fee was 60,000 rupees, right? Similarly, you can see different diseases, and you will also see that a particular treatment is repeating because different employees might have gone through the same treatments as well. So what is a common column between the department table and the treatment table? Anybody? What is the common column, guys?
Department number.
It is a short form, I think, of treatment name.
No, my question is, what is a common column between the department table and the treatment table?
Department number.
Department number.
So we got department number, dep underscore no, because that particular column happens to be here, as well as if you open the department table, you will see that dep underscore number is there as well. So using this common column dep underscore number, we can actually find out, Jhansi, it's actually department underscore number, it's not the treatment name, because if you go to the department table now, you will find dep underscore no is also there, which basically means This is the common column between the two tables. And using this common column, we can actually analyze a lot of information between these two tables, right? Now, so this is how we have understood the tables. Now let's go ahead and import these tables. So first we will import the department table, then we will import the treatment table. So let's go back where?
To that Google, where we are trying to make that tables, there we have to insert it.
Let's go there. Now it says what? Create the table from an empty table. Are we creating an empty table?
No, sir.
So let's click on the drop down here. And let's go to upload. So you can see so many options are there. You could actually upload the table directly from Google Drive and so many different storage places, but we will upload because we have already downloaded. So we'll go to upload. Then it says select the file. I don't have to tell you what to do there. Browse for that file. So as I said, we want to first import the departments.
Sir, are we supposed to close that sheet while uploading, or
no, you don't need to? You don't need to close that file. Click on open. Now it's automatically finds this file format as CSV. The project name is fine. The dataset name is fine. And now here, give a table name, which is again in small case. Give it name, logical name. Of course, since it's a departments table, so let's call it departments only, without any space. Departments or department? Are you calling it department or departments? Whatever you prefer. I'll leave it up to you. Departments. Okay. It's a native table. Let it be a native table is fine. And now one very interesting thing about Google BigQuery, not there in many of the database platforms, schema, auto detect. Now, what is a schema? Go ahead and open the department table in Excel that you have already opened. I'll tell you what is the meaning of schema. So here, schema basically means, in this context, means the data types of individual columns. For example, here, department number looks like it is numeric, which in other words also called as integer. Then department name looks like it is text or string or character, right? Similarly, if we had a date of birth, then it would have been date. If we had status like paid fees or not paid fees, yes, no, true, false, or 0, 1, that would have been binary. So 4 data types are common across the industry. All database management system and reporting tools will support them: numeric, text, binary or Boolean, which is true and false. And the fourth one I said is date and time. Irrespective of the database management software that you're using and irrespective of the reporting tool you're using, these 4 basic data types would always be there. So schema in this case essentially means that what are the different columns that we're importing and what are the data types of those columns. Now go back to Google BigQuery. This option is there to auto detect, which basically means that Google is saying that, okay, I will read the data that you're trying to import and I will assign the data type to individual column after creating them based on the data that already exists in that table. So this is kind of an artificial intelligence that Google promotes in their own platform, right? But it won't be there in most of the other databases. You'll have to manually kind of select the right data types. So let's go ahead with do auto detect. Yeah. Now, so schema will be automatically generated. We are not concerned about it. It takes care of a lot of headache, believe me. And then click on create table. Now, what we are doing is now we have imported the data, and then using that imported data, we're creating a new table. Perfect. Now it says the departments table is created. You can see this is the project, this is the data set, and this is our first table, right? Now, of course, we are curious to know the content of the table, whether the actual table has been imported or not. So why don't we click on the 3 dots here against the table, and let's see if there is some option. Click on the 3 dots against the table, and let's see there is an option called as open.
Shall I click on that, sir?
Sir,
Yes.
Hello,
Please.
sir.
Yes.
Just in the create tables, I've uploaded a department CSV file. Then in the destination, in the table, what we should,
Name is
which table we
department.
have to
Give it a department name.
department only, right?
Yeah, department.
Okay. Okay.
Yeah. Okay then. Now here we opened the table that we just imported, and if you notice, it has two columns. This is the schema right now. Department number and the data type is integer. Department name and the data type is string. Automatically detected. Correct. This is fine. Very good. Now we will go and preview it also. This is the schema of the table. This is the design of the table. Now we will preview the data in the table. Let's go ahead and preview it.
Shall I click on it, sir?
No, preview it. Now this gives you a preview. What is it giving you, Kirti? The actual, the kind of a look into the data. Remember, and just we are now comfortable that okay, schema is right. That means the data types are right, and the data that is imported is also kind of matching with the data that we had in our source, right? Clear?
Yes, sir.
And there are 15 rows that we were able to import. And if you want, you can go ahead and quickly match with the number of rows that was there in the source table as well in Excel, right? So this is where we have imported the table. Now let's go ahead and import the treatments table as well quickly. I will this time not help you. You will do it yourself. You want to import the table in where?
Dataset.
Dataset. Perfect.
Create table, right, sir?
Yes.
Sir, schema, we can do it auto detect or something else.
Auto detect.
Okay.
Go to the first option. Don't miss any option. So create table from where? You want to import the treatments table first. Let's go ahead and import the treatments table. Now, the name of the table, all in small case. Remember, it is case sensitive. Treatment. Native table is fine. Schema, let it be auto detect. And then create table. Perfect. You would not realize, how much of computational power is behind this platform, because all these are done very quickly in Google BigQuery platform. A lot of times, depending on the size of the data that we are importing, it may end up taking a lot more time in many other tools. But this is a cloud hosted Google Cloud platform, very fast infrastructure is there. So now let's open this table and let's see. Open.
Yes, sir.
Open the first one. Yeah, open.
Sir, there are many other platforms like SQLite or server and stuff. This in what way this is much better than them?
Well, I mean, this is cloud hosted. It is by Google platform. Actually, it is a MySQL database management software running behind Google Cloud platform. But it's an open source software, so they have added a lot of things. Just like Android, right? Different companies kind of customize it, right? But it is open source. So Google Cloud platform has taken MySQL database management system, which is an open source open source database platform, and they have installed it in their cloud data centers. And they have kind of customized it, made it a little more interesting, and gave a very good user interface to it. And it is fast because it is hosted on Google's infrastructure. It is very, very fast. So you can see these are the columns: treatment ID, dep underscore number, treatment name, fees, and all these columns are imported. Very good. 124 rows there. Now, great. Now, similarly, you can import the employees table as well, but you can do that later. No worries. You can do that later. Okay. Now, what we want to do is that we got the data, we got the project, we got the data set, and we got the tables as well that we wanted. We have verified that the tables data is also loaded. Now we want to start our analysis. Okay. Now, when we have to analyze the data, there are a couple of things that we will end up doing, guys. As I said, if you want to analyze the data, then there should be some business questions first, right? Now, hey, Kirti, thank you. Let me share my screen now.
Okay, sir. Thank you, sir.
Thank you, Kirti. Kirti was very fast, very quick, ready. So Kirti, you should give yourself a round of applause because you did exactly what I told you, and that too very quickly. Now, couple of things that we will do, guys. Yeah, I am going to run some SQL queries in order to make some decisions using the data that we have loaded in my database, hospital data set. I've named it a hospital data set, and these are the different 3 tables that I've already imported. Let's say I go to any one of these, it doesn't matter which one. I go to any one of these and I click on that table. It gives me an option to query it. So you can see the query here, or you can click on the 3 dots here and you can go to query. Now, when you go to query, it'll open another tab here. It'll open another tab here. And then here it says select space from, and then the name of this entire folder, entire path. So this is your, if you notice, this is your project, this is your data set, and this is your table. I get a point. Project, data set, table. Is that making sense, guys? Now, here we will start writing our first set of SQL statements in order to analyze the data. If you remember, I told you when I was introducing your statement types, I said this is the statement where we will spend 90% of our time when we work with SQL, because this is the statement which helps us to extract or read the data, which helps us to make decisions, right? Say, for example, I come over here in Google Cloud Platform. So there is a select statement you can already see, and select statement basic syntax is this: select. Sorry about my handwriting. From and where. Now, after from, what we write is project name dot dataset name dot table name, and we put them under pair of ticks. Tick is not a single quote. Tick is a symbol before number 1 in your keyboard, just below escape. If you notice, there is a tilde sign, like a sine wave sign, and that is your single quote, a single tick. So you put the project name, the dot dataset name, dot table name, the entire path of the table under pair of ticks. Schema, Jhansi, just go through the recording again. I did explain schemas where I explained the data types, 4 data types, and so forth. And maybe you can, stay after the session is over. I can explain it to you. So select from project dot dataset dot table name, and that is what is happening here. From, after from, you write the table name, but in order to go to the table name, we got the project name dot the dataset name dot the department name. Let's say I have multiple projects here. If you have only one project, then you can skip the project name also, right? But I'll tell you, what is the quickest way of getting to this. So say, for example, I delete everything. I write select, and in the next line I write from, and in the next line I write where, right? So I go back to from, and then I write, I want to get the data from, let's say, departments table. So I'll write department, DEP, and then I wait, and then it suggests me the entire folder path, and I press tab. I can double click on it with my mouse, or I can press tab, and it gives me the entire path for that table. Where, now let's say I remove where is also optional, and I put a semicolon. Semicolon is like in English, we have a dot at the end, right? Period at the end. So semicolon plays the same role. It is the mandatory end of SQL statement character. You have to give a semicolon in order to say that this statement is over. So grammatically, if you want to be correct in an English statement as well, you have to put a dot at the end. So select what from this table. So let's say I want to select all the columns of this table. So I can press star, which basically means that I'm interested to select all the columns. I'm lazy, that I don't want to, I don't even know, or maybe I don't care. I want to select all the columns. Now, in order to run this statement, I select the statement. It's important to select the statement and click on run, or you press Control Enter. I can press Control Enter after selecting, or I can press on Run button here. When I run it, down below here, you will see results. Okay, it is running and it gives me the result. I will drag it up. I can see all the results. And I can see that there are 15 rows which were originally there. And if I don't want to see the result, you can always drag it down again. So that is our first query, which gives me, what does it give me? Let me write a note for myself. When I have to write a note in SQL, especially in Google BigQuery platform or MySQL, you put them under pair of / asterisk and asterisk /. So this is considered when whatever you will put under pair of / asterisk and asterisk / would be considered as a comment. So this will give me list all the data from the departments table. That is what this is giving me. It's like a comment for myself. Now let's look at some questions here. Let's look at one question, which is, let me look at this. It says display the records of the employees who have resigned. Display the record of the employees who have resigned. So this is a business question that I prepared already. Display the records where the employee has resigned. Now, if you remember the employee table, I have opened it in Excel file as well, just to show, just to see that the column names here. So I've got these column names. So I'm only interested probably in employee ID and maybe the first name, where date of resignation is not null. Date of resignation is null, meaning it has the employee has not resigned. So how do I write something like that? So select from, and this time I want to write employee, so I write EMP and then press tab. Wait for a second. Where now this time there is a condition, so it's like a filter in Excel. Where what column? The column name is date of resignation is not null, and semicolon, and then this time I will select specific column instead of selecting all the columns, which in any case is not a great habit to do. Employee ID, comma, let's say first name, F name, comma, date of resignation, press tab. So I've got the 3 columns that I've selected, and I select this, and the shortcut to run it is Control Enter. So I press it, Control Enter, or I go to the run button here and it runs it. And it gives me the data of all those people who have resigned and their date of resignation as well. If I want, I can save this query into a Google Sheet, into a CSV file, download this output of select query. You can download, take it into Excel, visualize it, take into Google Sheet, visualize it, take into Python, run machine learning algorithm, and so forth. And let's do some more analysis here, guys. Some more analysis. Let's say I want to find the number of males and females in each employee category. Number of males and females in each employee category. Find the number of males and females in each employee category. So I'm going to create a dummy table. Like you take pen and paper and create what are the ideal columns that we want in the output. Number of males of males. So there should be a gender column, comma, in each employee type category, in each employee type. So there is a employee type here as well. So we will have employee type also. Let's put employee type. And then count. So summarizing the data. So we are going to summarize the data here. So here I want to showcase, select from. Now this time I'm writing everything in small case. So you can write the commands in small case, no problem. But the field name, the table names should be written in the same case that is there in the database. So from employee tab. Now there is no where condition here. I want to group the data. See how easy it is to summarize it. I want to group the data by employee type, comma. I want to group the data by gender, semicolon, and then I want to showcase only employee type, gender, and then just like Excel has functions, count, sum, average, and so forth, SQL also has function. So I'm going to use a function count, and I'm going to apply this function into the identifier, into the column which contains data for every employee, which is employee underscore ID. Employee underscore ID as total as. Now let's say I don't write as. So now select from this table, group the data by employee type, gender, and then I'm going to run the statement. Okay, gender, I'm not sure if the gender is there. It's called as sex. Okay, it's not gender, it's sex. So look at the error message that I got, unrecognized name, which gave me a hint that I must have misspelled or written a wrong column name. So when I run this statement, I can see the output. All right, employee type, gender, number of people. F0 is a funny column name. F0. Why it is a funny column name? Because this count of ID was not there in the original table. So it is a derived column. It's a calculated column. So now I will write, I'll give it a nickname as. Remember, this is a select query. That means we're just reading the data. We're not making any changes to the original data tables. Okay, no changes are allowed to be made using select statement. So I will show this table, show this column's output count of employee ID as, let's say, total count. Now I'll select the command again. And then control enter, and it runs it. And I can see the output. And you can see there are 30 males, 30 females, and so forth. Now, let's do some more business questions. Now it says, list the, let's do, let me not use that query. Let me use another query here. Let's find out, list the treatments, list the top 5 treatments. List the top 5 treatments, because if you remember in the treatments table, we have gotten multiple treatment name and their fees, right? I want to find out which treatment name had the highest fee. Let's do that. Which treatment name has the top treatments with the highest fee amount? That means where people are spending most money, or where the company is spending most money. So again, I'll write select from. Now, which table, guys? Which table should I select here? Should we get the data from? Treatments. Right? Press tab, right, Astha. And here I'm going to use a very interesting command called as order by. Order by is just to sort the data. Order by which column here? Order by which column? Order by which column of the treatment table?
Fees.
By fees. That's right, Sumanna. By fees. In which order? Ascending order or DSC order? Descending order?
Ascending order.
No, descending order.
Descending order.
Increasing order. Starting from the highest, then the lowest. Descending order. Order by fees descending. Then semicolon. And then since it says treatment, so I want treatment name, and it gives me this, and then I will have fees. These are the only things that I'm interested to find. And then I run this statement. I get the data. Let's see if I've gotten the data. Yes, I've gotten the data, but this is not giving me top 5. This is giving all the 124 treatments that might have happened. Yes, it is giving me the highest, the treatment which costed the most as the first value, but it's not giving me the top 5. In order to get the top 5, there is an interesting thing here available called as limit. Limit and 5. What does it do? It limits the number of records that you can see in the output. So I select this statement, and then I run this statement, and then it only show me top 5 treatments. Top 5 treatments, guys. You can see these are the top 5.
Can we use top function also?
Top is not a command available in Google BigQuery platform because it works on SQL statements.
Okay.
MySQL doesn't recognize top. If it was a Microsoft SQL Server database, then it would have recognized top. But then it doesn't have limit. So limit, what it does is that it will only limit the number of rows that we want to see. Rishi, if you want to know the offset, what offset does is, let's say if I write 2, 1. What is the meaning of this? Here, what we are doing is now offset doesn't work in Google BigQuery, but it works in MySQL database in general. What this would have done is that it would have offsetted. That means it would have ignored the first 2 rows and would have given you the next row. In this case, it would have ignored. It won't work here in Google BigQuery. It doesn't support it. it would have ignored these two data sets, these two records, and would have given you the next one, which is heart transplant. But anyway, we'll not go to that yet. Okay, for now, we were interested in getting this. And then I run this statement and it gives me the top 5. Yeah, because SQL Workbench, Rishi, is it runs on MySQL. This is not a typical MySQL. This is a Google BigQuery modified version of MySQL. So few of the commands you will see doesn't work here, which work there, and so on forth. Now, so far we have worked with single table. Let's try and get the data from multiple tables together. What I mean to say is that if you remember, between the treatment table, there is a department underscore number, and the department table, we have a common column called as dep underscore number. What does the department table has? What does the department table have which treatment table does not have is department name. As you can see, it's a department name, which is not there in the treatment table. We have department number, but we don't know the department name. If you want to find out which are the top department names in terms of the fee given for medical treatment, so you can get by joining these two tables, by merging these two tables on the basis of this common column. So in SQL, one of the very interesting option that is available is to be able to join multiple tables using common columns. So how can we join multiple tables using common column? Let's say my question is a very simple question. List the department name and the fee spent in that department. Now the fee is a column that is going to come from the treatment table, and the department name is a column that is going to come from the department table. So whenever in your ideal output, you have columns. In your ideal output, we have columns from two different tables, or two or more different tables. You end up joining the two tables. You end up joining in SQL. So here we have department name. I'm writing in short form DN, and fee. Now department name is going to come from the department table and fee is going to come from the treatment table. Since we want in the output columns from multiple tables, and hence we will have to join the table. So how would we join the two tables? So after from, normally we have been writing a single table. This time we will use multiple tables. How? So I'll write from department as, I'm going to give a department a nickname as B inner join. Inner join is like finding the common rows between the table. So inner join, which with table with the treatment table as T. So we're inner joining these two tables on the basis of which column, guys? On the basis of which column? ID. Inner joining on the basis of the department underscore number, the DEP underscore number. So we will write where D dot meaning from the D table, which is now short form nickname for departments table. Otherwise, if I had not given a nickname here as D, then I had to write departments again here. So as on D dot department number is equals to T, which is a short form given to treatment table department number. So we have joined the two tables, semicolon. I put a semicolon, then I go back to select statement and I select the department name tab, comma, fees. Ideally speaking, you should have written the nickname before the table nickname before this D dot name and T dot fees, ideally speaking. So here, let's follow the best practice. I've given the nickname that I had given to the table. This basically means that this column is from the department table and this column is from the treatment table. And since we are working in a multi-table scenario, so it is helpful. So now you can see department name has come from the department table and fees has come from the treatment table in a synchronized fashion. So just to review the command again, it was so easy that, we just said that this table inner join as the other table. Inner join basically gives you the common rows between the table. So if you remember the Venn diagram from your school days, set theory. So this is your department table and this is your treatment table. And this basically means the common rows between the table. So common rows are there between the table on the basis of the common column here. Got it? Now let's do the last query because I've already taken 7 extra minutes. I'll do the last query here, and I will upload a few queries in our YouTube channel for you to practice. Okay, I'll upload not more than 10 queries, guys. Okay, do try to practice on those 10 queries, and I'll also upload the solution to those 10 queries that you can verify once you are tried by yourself. So the last query that I want to see is, I've got the department name, I've got the fees here, but remember, same data set, Ronnie, same data set. I don't want you to, you can of course try your hand with other data sets, frame your own business question. Anyway, so the last question that I want to do here is, I want to find out the top 3 departments in terms of fees spent. I want to find out the top 3 departments in terms of fees spent. So that means what I want to do is that I want to group the data by department name or department number. And then I want to summarize that in sum total, the fees spent in each department. Because remember, in a particular department, there might have been multiple treatments done. So again, I want the data from 2 different tables. So we'll have to join the 2 tables. So I'll copy this much from here, from this query. And then I'll remove that dollar sign, that semicolon, sorry. And I will borrow that concept of grouping that we saw earlier. Group the data by which column this time? I will group the data by which column? Which column do I need to group the data by? I will group the data by, remember, I want to get the department-wise total spent. So department name, and I will just put it as d.department name just to be consistent, and semicolon, and then I'll select department d.department name, comma, sum of fees, total fees, sum of fees. Now when I run the statement, control enter after selecting it, don't forget to select the query before running it. Let's look at the result. So this is the result. The department-wise total fees. Remember, in one department, there might have been multiple treatments, so it has summarized, aggregated, and grouped them. So it is giving me for all the departments, all the 15 departments. But are we interested in all the 15 departments? We are not interested in all the 15 departments. We are only interested in top 3. So what should we do here, guys? We should limit it. Limit it by 3.
Limit 3.
However, before limiting, because remember top 3, so we should also do what?
Order by
Order the data by which column?
fees.
By fees in descending order, DESC for descending order. That way, we are sure that we will only be getting the departments. Okay, order by, not fees, actually order by sum of fees, sorry. Order by sum of fees. That is the reason why it is giving me this error. Control enter. And now, that is a very interesting thing that is going to happen is that will only show me 3 departments. So look at the complete sequence of event that is happening. First, we'll open these 2 tables and inner join them on the basis of this combination, this common column, right? So that we get access to all the columns from both the tables. And then it will group the data, aggregate the data, group the data by department names, so that if there are multiple treatments that has happened in a particular department, all of them will be grouped together. And then it goes to the select statement, it summarizes, that means finds the sum of it. And then it comes back to order by here, sorts the data by sum of fees in descending, decreasing order. And then it limits the number of records that we want to see in the output, so that we only see the top 3. So that's it. That is what is happening here, guys. So that gives you the top 3 departments. So as you can see, it is very English friendly one. It allows you to work with multiple tables, and complex analysis you can do using simple commands. And the best part is once you've written these commands, they become your intellectual property. You can have different databases and just change the table name, just change the column names and be done with it, right? I know it looks like, oh, I have to learn a lot of commands, but believe me, once you have done. So Sumana's question is, why did we use sum of fees here? The reason why we use sum of fees is, Sumana, remember, in a particular department, there might have been multiple treatments, Sumana. If you look at the data here in the treatment table, let's say, for example, this department, 4, and it might come again somewhere later. Multiple treatments are happening for 500 rupees, 5,000 rupees, and similarly, there can be multiple. So what I've done is that I've grouped the data and then I've summarized, that means found the total of all the fees within each department. Sumana. Is that making sense, Sumana? All right, guys.
Similarly, we can get max, mean.
We can get anything. We can get we can summarize the data and we can get a lot of information here. Max of fees. We can get min of fees. We can get average of fees. Using AVG command.
Hello, sir. I have one question.
Sure.
Sir, basically, I work on Power BI.
Absolutely.
So in Power BI, we have this option for uploading data from SQL server.
Absolutely right.
So how does how I'm not able to correlate this thing with that, how it will work on that?
Absolutely. So what happens is, Kirti, when you have data, so data resides in databases, Kirti, right?
Yes, sir.
So let's say we created a data set here, we imported the tables here, database is here, the data is here. Now you can connect this Power Query or Power BI, right? Say for example, in Google, we have something called as, which is equivalent to, sorry. So in Google Cloud Platform, we have something called as Google Data Studio. So you can actually take this data and connect it to Data Studio, which is the equivalent of Power BI in Google ecosystem. And so now what happens is, these queries that we've written on this database are linked. The output of these queries are linked to Power BI, where you can actually go ahead and visualize the data much better. The SQL platform is not a visualization platform. For visualization, you need reporting tools. For running machine learning algorithms, you need reporting tools, right? But the data resides in these databases. I get a point. So you, yes, in Power BI, you will connect to the databases, or you will connect to the queries that you've written in the database to extract the data, and then in Power BI you will end up visualizing them. Or in tab.
Means from that SQL that button we click on that, where we have to connect this database, and
Absolutely.
Then we have to upload.
Absolutely.
Okay.
And then, you know, I mean, if you go to Ivy's YouTube channel, just search for how to how to connect to a cloud database. Just search in our YouTube channel. I have recorded a video only there, and you will find that how can you connect a reporting tool like Excel to a cloud database as well, and get the data into Excel. So I'll give you a simple thing. You know, I don't have Power BI installed on my laptop, but let's say if I go to to an Excel file, just out of curiosity, since you're curious. So if you go to data, and under data here, there is something. The first thing is get data from database or from other sources. If you want to get it from non-Microsoft database, from ODBC. So I've got a MySQL database installation in my local machine. So I'll pull the data from there. So if I go to that, it'll ask me, of course, it'll ask me where it is, where the database is. So I've already created a data source. Data source basically has the URL of the database where I've installed it. And let's say I go to this one, which is a local option. And here I can write a query as well. So select from student.student where sex equals to female. I'm writing a very simple select command query. I've written it and I press OK. Now what it is going to do is that it is going to connect to the local installation of the database server that I have MySQL, and it will go to a particular data set there, and it will go to the table and it'll import the data. So this is the data that I've imported, and I'm going to load it. Now when I load it here, It is going to be loaded. And why am I loading it on Excel? Because in Excel, I can visualize the data much better than a database. Database platforms or a SQL platform or SQL platform will not have any charts or anything that we can easily find in a visualization platform like Excel or Power BI or Tableau. Did you understand this? So similarly, in Power BI as well, you have data, get data, and then you can actually connect it to any data source. And while connecting, you have an option to run an SQL statement to summarize the data while importing it. All right, guys, any other question? Otherwise, I will summarize what we just discussed today.
Hello, sir.
Yes, Suman.
Sometimes someone asks how to create database. Do you know view? Do you know store procedure?
Absolutely.
So,
Sumana, those are part of DDL statements. And, Sumana, I'm not sure if you're IB students. If you're an IB student, you
yes, I am previously IB student.
So then you must have learned in my classes how to create a database, how to create a view, how to create a stored procedure. How to create a database comes under database DDL statements, which
yes,
is
sir. I'm just asking. It is not depend on development. It's
No.
all about administration.
No, not necessarily. It's a administration job. You should at least have some understanding of creating a database. You should have some understanding of creating tables in it, importing the data, and changing the some of the basic things you must know. Everybody should know.
Okay.
Otherwise, you're handicapped. You can't just rely on select statement. Yes, 90% of the time we use select statement. However, it's not, those commands are not very, very difficult to learn at all.
Okay, sir. Thank you.
All right, guys. So what are the things that we learned today? We learned what SQL is. We learned that SQL is a common database language which all the database platforms speak, and also all the reporting tools speak, right? So if you want to connect to the database in order to send instructions to the database management software, then you will use SQL or structured query language. SQL statements are divided into 4 statement types: database definition language statement or DDL statement, which allows you to create the design and alter the design; database manipulation language statement, which allows you to insert the data and manipulate the data and also query the data; and database control language statement used typically by the database administrators to grant and revoke access; and transaction control language also used by data engineers to kind of do backup planning. So that's that. And then we learned in Google BigQuery platform, how do you create a project, how do you create a data set, and how do you create tables, and then how do you import the data from an Excel CSV file, and then how do you start running or how do you start analyzing the data in Google BigQuery platform using simple SQL statements. So what I'm going to do is, guys, if you go to IB's YouTube channel, this video will be recorded there by tomorrow. I'm going to upload the dataset link as well there, and I'm going to give you 10 questions, guys, and I'm going to give you this file that I have worked upon today. You can use this file as a command reference, and you can try and solve those 10 questions that I'm going to upload there, guys. Thanks a lot for attending today's session. Now, you're free to go if you want, but before you go, do subscribe to YouTube, IB's YouTube channel. It's if you search for IB Pro School YouTube, you'll find a lot of interesting videos there related to the data world. Not just data science, data engineering, data analytics, and so forth. A lot of industry speakers are also there who have given their thoughts on different things. So that's one. And similarly, I would suggest you get connected with me on LinkedIn or on Twitter. So if you just search Prateek IB on Google, you'll find my link over here. The reason why I'm asking you to be connected is that if you have any career questions, you can always ask me. And also through me, you get connected to a lot of thousands, tens of thousands of people from the data world. Thanks a lot, guys, for attending today's session. I'm going to be here for the next 4 or 5 minutes. My name is Prateek Agrawal, and I'll see you guys again. If you want to see more of my videos, then go to IB's YouTube channel and subscribe to it. Alrighty, now some questions that I have not answered. So Rishi had asked one question that, sir, do ETL data pipelines covered in data engineering? Yes, that's exactly what the data engineers are supposed to do. Create the entire pipeline as to how the data travels from source, data sources, to data ingestion, to databases, data warehouses, and then to the presentation of the reporting tools. That entire pipeline, before the data analyst or the data scientist start using the data, that entire backend pipeline, technology pipeline, is managed by data engineers. Yes, so they use tools like Hive, Kafka for real-time streaming, and most of these things are done on cloud. Yeah, but not necessarily for data scientists. But believe me, they are not very difficult to learn also. Thank you, Mayur. There is a feedback link, guys. Yeah. Thank you, Rishi. And guys, thanks a lot for today's session and happy Diwali. Have a good one, guys. Bye-bye.
Same to you, sir. Thank you so much.
Bye-bye.
Thank you, sir. Bye, sir.
Thank you for attending the session. Sure, you found the session insightful and knowledgeable. Thank you, Prateek sir. On the festive time, we are offering a discount from rupees 5,000 to rupees 1,000, depending on the course you all take. So please get in touch with us, with the respective city councillors, and we'll be happy to give you more information. And looking forward again to meet you in the next bootcamp session. Thank you so much.
Thank you, everybody.
Please please fill the feedback form. That's very important for us.
Thank you.